We now move on to our next panel, which is on the key technologies to watch. So we have a very distinguished panel here of experts with very long experiences. They're all published authors and etc. And they will speak on three different key technologies, which we've already touched on in the previous sessions. So if you're just joining us, we are now, this is the virtual NatSatTel 2025. And we are now on the second panel discussion on key technologies to watch. And we are, like I said, we have three speakers. The first one will be Armand Musey. He's president of Summit Ridge Group, who will talk about direct-to-device, which was touched on already in the previous presentations. And then we will have Bruce Elbert, president of Application Technology Strategy. And he will talk about ground and space segment network technologies. And finally, but not the least, Thomas Wrede, Managing Director of Technology Vision Consulting, who will talk about broadcast applications for satellite. So we'll start with, now this is a little different from the first panel because there's three different topics. So we will discuss, we'll have each panelist will have a 5-minute presentation, and then we'll have a few minutes of discussion on that topic, and then we move on to the next topic. And then at the very end, there will be a panel discussion, and the audience, again, remind you that you are welcome to join us and ask questions or comments in the chat button. There's a chat button in the webcast just below the screen that you see. So without further ado, our first speaker is Armand Musey. He's the president and founder of Summit Ridge Group. He has many years of experience in equity research, investment banking, and consulting experience. Prior to Summit Ridge Group, he was with Bank of America Securities and later Solomon Smith Brownie. He was an all-American institutional investor. He wrote the technology handbook, the telecommunications handbook. And recently he did a study together with Tim Farrar on this very topic that he's talking about, direct-to-device. So Armand?
Can you hear me now?
Now, yes, we can hear you now.
Okay, perfect. Thank you. And Virgil, it's a pleasure to be here. Just for a quick background, Summit Ridge Group is a consulting firm that I started several years ago after I left Wall Street. And we do or focus on valuation-related issues. And I sometimes joke that we do valuations before deals for due diligence and fairness opinions. When the deals go bad, we do litigation support. And when things go really bad, we do restructuring work. We also do a lot of advisory to investment firms, particularly distressed debt funds, who sometimes buy debt hoping that we'll pay a coupon, and then the things go bad and they're trying to figure out what they really have. We also do some industry consulting. In fact, we're doing some spectrum clearing for one of the D2D players. So before I start maybe with D2D, we probably go on to the next slide. We know that I want to make a very big observation about LEO, because I think particularly the regulators lump LEO into, there's GEO and there's LEO. But I think really from a big picture perspective, LEO really is a tale of two cities. There's the big constellations, which are using higher frequencies, where there's a fair amount of spectrum available. And the spectrum can be shared in different ways, although there's obviously many discussions about how that sharing takes place, but it can be shared to some extent. And then there's the smaller LEO projects, which are generally using lower frequencies. Particularly a D2D has to use lower frequencies so that it can effectively get to your handset and penetrate at least some foliage, which are also lower capital, have less capital intensity, so there's potentially more entrants. But the problem is when you get down to the lower frequencies, there's less spectrum available. And not only is there less spectrum available, you also have the terrestrial wireless companies also interested in those same rough spectrum frequencies. And so the spectrum availability gets very tight because there's more entrants. You're competing against terrestrial to a greater degree. And it can't really be shared because when you get down to particularly D to D and you're using omnidirectional antennas on a cell phone, you can't point at the satellite, and so the spectrum can't be shared, and things get really, really tight. Can you move to the next slide?
Next slide.
Next slide, thank you. Okay, so this is a list of some of the activities that D to D does. It starts off with text messaging, moving to voice, potentially data, and even broadband. And so on top of the spectrum constraints, the industry is moving toward applications that become more and more bandwidth intensive over time. And that just exacerbates the problem. And then this gets even worse because, of course, we're dealing with LEOs, and LEOs are global. And so the operators pretty much need this spectrum to be globally harmonized, or at least quasi-globally harmonized, which then reduces the spectrum availability even more. So it becomes a very, very tough battle for the D2D providers to find appropriate spectrum. Go to the next slide. So I've outlined the D2D providers here and what spectrum bands they're looking at. Some of them, for instance, you have Starlink using right now T-Mobile's PCS band in the US. That's very expensive. And I don't think that's really the long-term solution. I think they're looking at using other spectrum bands that are less expensive than giving up terrestrial spectrum, which goes for easily $1 per megahertz pop, if not more. But you can see the sort of battles there. I recently wrote a white paper with Tim Farrar, who many of you know, and we looked at what are sort of the options here in terms of spectrum for additional D2D entrants. And after sort of going through the big LEO spectrum, the L band, and then looking at the S band, particularly Globalstar's S band, sort of thought that was the band that was most attractive because it's quasi-globally harmonized. There's not very few people using it. And quite frankly, EchoStar looks like they could use some funds. So I thought that was probably the most logical place right now. But it is going to be a battle. And interestingly, I think many of the satellite entrants have sort of ultimately won or lost in the marketplace. I think when it comes to D2D, the winners and losers may be sorted earlier in the phase, basically based on their ability to get spectrum that they can use that's a suitable bandwidth. This also raises sort of the question about, and this is sort of an unknown, that we have some of the players are suggesting that they would like to provide video and even 100 plus megabits per second. Sort of what is ultimately the demand for that going to be, given the spectrum constraints, and can that be justified? And I think that's going to be a big issue that we're going to be facing in the next couple of years. The other thing, because I realize that we're speaking to to a certain extent, a European audience today, there's been a lot of discussion about in the industry about European systems versus U.S. systems, and wanting to sort of keep sort of there's an America first and sort of a Europe first type strategy out there. With LEOs, I think that becomes extraordinarily difficult. The traditional problem with LEOs is, of course, that 70% of the world is covered by water. And then you start to take out now Russia and remove China, and the market becomes even tougher. If we then start splitting it between the European systems and the US systems, the market gets split even again. And I think then the economics become even much tougher. So it's not meant to be a political argument, but more of just an economic one, that LEOs by their nature are global, and we're already limited. And if we get split again, I think it's very problematic for the industry. And I'll leave it to the next topic. Oh, I'm sort of done.
Good.
Well, thank you, Armand. I have a question, which is the question that I posed to Vivek in his keynote, where he spoke about the prospects of D2D, and he mentioned that's one of the fastest growing segments of the industry. Since you're a financial expert, Armand, do you think this time around, D2D has been tried before, and 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 do you think this time around it will be a commercial success?
I think it depends on what you mean by commercial success.
Which means revenues, which means profits.
So I think right now, Global Star is available on all the new iPhones that are coming out or have come out in the last 2 years or so, and it's providing free texting service. That's probably the most important thing. And you think about it, it's really revolutionized emergency communications. That pretty much most places on the planet you can get a free text message through. That's the most important thing, and it's free with every Apple phone or every iPhone. And I think that is financially justifiable to Apple because they can sell more iPhones, they can get people to upgrade to the new version, and it's financially viable from that perspective. However, the real challenge is going to be, will people pay more to get an upgraded service? Will they pay more to get internet or video and to watch TikTok when they're out camping? I think that's the real question. So I think the financial viability may be more subtle and really come to both operators who can offer that as part of their service, or to the handset manufacturers, as opposed to standalone companies offering it for a fee.
Right.
I think that's going to be more challenging.
Well, the other panelists, Thomas or Bruce, do you have any questions for Armand? I know this is a topic that you also follow.
I have not too much to add at this point in time, Virgil. I think the main question is the question of the economics. I mean, what does a service cost? That has been mentioned several times, and that's a key issue. Consumers in those limited markets for these operators not covered by C or not being the C, I mean, they won't pay a lot of money to have those services.
Yeah, and also Armand, as you know very well, most of the phones are in developing countries, which have very limited ARPUs, average rate of per unit, revenues per unit. So, here in the US or in Europe, they can pay more. Like you said, will they pay more when they're camping or where they're roaming, where there's very little or no connection? What about those in Africa, in Latin America, in parts of Asia?
So I think the demand for it is more. It's a little bit less obvious. So I live in New York City. I have the iPhone, right, which has the Global Star emergency service, and that makes me feel comfortable because my wife is out in the car and it breaks down somewhere, and I know she can get an emergency message through, and that makes me choose maybe an iPhone over an Android. But am I going to pay an extra $5 a month for it? Probably not. But there's a lot of people, and I may never use it. My wife may never use it, but okay, it's nice to have because I know if an emergency it's there, it's helpful. But I'm probably not going to pay a lot extra for it. But it may make me decide not to leave my carrier or to buy a certain phone.
Right. All right. Well, if there's no other questions for Armand, we'll come back to it later. We'll move on to our next speaker, which is Bruce Elbert. He's a leading expert on space technology and satellite communications. He's an engineer, project leader and consultant with over 50 years experience. He worked for Hughes most of his Hughes Communications for most of his career, where he was involved in many key satellite projects, including Palapa and AsiaSat, among others. And he's a published author of many standard reference books. So he will talk about the ground and space segment network technologies. So Bruce?
Yes, hello. Are you hearing me okay, Virgil?
Yes. Yes, Bruce, you're coming in
Wonderful.
loud and clear.
Okay, hello from Texas, USA. I will present on key technologies throughout the entire system, the space and the ground segments. And I appreciate the comments you've heard already. I think they're very practical, very realistic that we've heard from the other speakers. I want to thank Virgil Laboratory of Satellite Markets and Research, as well as the organizers Intersputnik. Next slide. Virgil has already introduced me. Thank you very much. So I did spend 25 years with Hughes Aircraft Company, which had a satellite operating subsidiary that I was in for 11 of the 25, but I'm very familiar with spacecraft, their operation, as well as the ground segment and putting it together, as in Indonesia that Virgil mentioned. That was in the 70s. And then moving on later to geomobile communication satellites like Thuraya in the Middle East. I retired in 1999 to set up my own consulting practice, which I call Application Technology Strategy. ATS is now 25 years old. It's provided me with the opportunity to assist a wide range of US and international client organizations with my expertise in engineering, operations, and business development. As a systems engineer with 3 different US industrial organizations, I took part in several innovative programs, as we've alluded to, and overall operations, including the business side of it. And he mentioned about the books I've written. I've also been a teacher, teaching satellite technology through UCLA, University of Wisconsin, and Applied Technology Institute, which is a US-based private training organization located near Washington, D.C. And my website is applicationstrategy.com. Next slide, please. All right, so let's get into technology. What is technology anyway? I mean, I studied it as an engineer. Broadly defined, it's anything made by humans to produce a required outcome. In our world, this includes both hardware and software. Satellite communications first includes the space segment, composed of orbiting satellites that act as repeater stations for service to users on or around the Earth. We also need to include getting to orbit. Now, ground segments are not directly part of a space segment, but the space segment cannot provide service without it. It includes the network and the users. So I divide the technologies applicable to these into 3 classes. Number 1, components. They are developed and produced as individually identifiable items. As such, they come to us by a variety of suppliers who design, manufacture, and distribute them. These may be the technologies that Virgil has referred to. But you put these together into the second class, systems, that are composed of a plethora of components, both existing and newly developed. That's why the space industry is so unique in its introduction of technology, but it has to be proven, doesn't it? Okay, the third, bringing this all together, are processes that exercise the components to perform a wide variety of functions. That is, processes are made possible through human staff, which was the old way to do it, and now through software, including, as Virgil has brought up, artificial intelligence. There's another class of kind of component, I'll say, and it is standards. Standards are a class of component, and they can have a role. So I'm going to address all of these. Next slide. So what you see here is a breakdown of those 4 classes: the devices, the systems, the processes, the standards. And then under the space segment, I've listed a collection of contemporary technologies, and likewise on the ground segment. And you've heard many of these mentioned by the previous speakers. So let's take a look at this presentation in a modern satellite communication system. I've differentiated between technological elements of the space and those of the ground. We really can't get these mixed up because when you put something into orbit, that device has to work in an orbital environment under remote control. And on the ground, as you saw from Brian's presentation, the person can carry the terminal in and set it up and it can take over, but still humans are usually involved physically on the ground. Okay, so let me talk about some of these that are in this chart, okay, that I think are important. Under space segment, on the technological device, the small spacecraft. Now, previous speakers have talked about small geostationary satellites, and that's a great idea. I mean, that's the first thing I worked with in the industry, almost a tabletop-sized geosatellite that required 30-meter antennas. But we don't want 30-meter antennas. Anyway, so the geosatellites are generally larger, but by small spacecraft, I'm talking about those used for the LEO broadband constellations. And Iridium, I'm not sure Iridium is a small spacecraft. It's, 2,000 pounds, I think. It's pretty large. The SpaceX, Starlink satellites and others, OneWeb, these are under 1,000 kilograms. So that's kind of what I mean by small spacecraft. And those are designed and manufactured much differently from the large ones. You don't have human beings going around bolting things together, testing components, testing it as a system, later as a system. No, it's done all at once. And you need a production line, and you're going to bring the cost down to $1 million or less, maybe $100,000 per spacecraft. So that's a different technology. Then we have onboard processors in space. We heard of software-defined satellite. In order to have a software-defined satellite, we need to do everything digitally. So that processor has evolved tremendously over the last 30 years. And it brings in beam-forming antennas. The next thing I want to mention. These are exotic and complicated, but boy, what they can do in directing bandwidth into a relatively small area and then having lots of beams means lots of service possible. The next under systems is the digital twin. Now, what on earth is that? Now, I've been interested in computer simulation since my master's degree days at the University of Maryland. And we want to simulate the functionality of a satellite and of a system, including the ground. And we want to be able to prove things out before we go to hardware. That's a digital twin. That's become very profound in the manufacturing environment and also in the operating environment. So I see that as an important technology. The next one under process is the supply chain. Oh, we've heard so much about the problems with the supply chain after COVID or during COVID, and today we're getting better at it. And there's always a question of make versus buy. Are we going to develop that component in-house, or are we going to go outside and then integrate it together? So there are different arguments there. The last is the standards under the space segment. And you see CCSDS and you see NASA something called TRL. That's Technology Readiness Level. Okay, NASA has come up with either 7 or 9 levels. And it starts off with something that's conceptual and in a laboratory and you can't launch it. And all the way up through all the stages until you get to something that's flight proven. Now, generally, we don't launch a new technology unless it's reached level 9. But what is level 9 exactly? So the devil is in the details there, and that's critical. And on the right, we've already heard mention on ground segment of planar arrays and self-pointing antennas. I want to drop down to systems, network management systems, especially for the constellations or a fleet of satellites, such as Mark was talking about with Inmarsat. The management of all those resources and keeping everything up and running and knowing the status is bedeviling. And then you throw in the possibility of a digital twin there and you really have a powerful scheme. I'll drop down to another standard at the bottom, SDN. That stands for Software Defined Network. At least one company is producing some products in that area, and we'll see if that doesn't end up being important. Next slide. I was going to take a lot of time to talk about concepts of how do we develop a new system. And I just want to kind of quickly go through this. Go ahead and run down all the W's and the H, 5 W's and 1 H, who, what, where, when, and how. Just go ahead and click it and we can see all of those. This list came from Google AI. That's what they defined each of them. But whenever you do a telecommunication project, whether it's land-based or it involves satellites, you have to answer the question of who are your customers, what is the service that you're going to be providing to them, and where are they located, the next bullet, and when is the service supposed to be up and running? How much time is going to be involved, and the how. The next one, the how is the engineering of it and the operating of it, and we often focus on that. The one that we don't really talk about is the last one, why. Why are we doing this? Explains the reason or cause. This is often ignored or even uncertain. This is the biggest question for leadership to answer. So let me give some examples of where it got answered in the most amazing way. First is Bell and the telephone. He envisioned this thing. He got it patented in 1876, and then we had AT&T come out from that, and everything about landlines. Then the next one is Marconi and the wireless. The first transatlantic connection, 1901, from Newfoundland, I think it to Ireland is where it went, and that started off that business. Then the next one I'll mention, you may not all be aware of, is Harold Rosen and Syncom. This was the first geosynchronous satellite. It was developed by Hughes Aircraft Company, launched in 1963. I was still in college at the time. I didn't join Hughes until 72. If you want to get the background on Rosen and Syncom, Wikipedia has a good article on Syncom, and it'll take you through the whole thing. All right, the next visionary, okay, the person who came up with the why is Barry Bertiger at Motorola there in Arizona. And he was the driving force behind Iridium. If you know Barry, you know this guy. He doesn't relent. He's at it, even though it wasn't his own money. The money came from Motorola, and the first call was made in 1998. I think Al Gore called somebody over, and that's not a joke. That's true. It was him. All right. And lastly, let's not forget Musk and SpaceX and Starlink. There is a man with vision, and he got it done. And the first demos were in 2020. Okay. So lastly, I want to thank you for listening. And this is my brief walk through technology. And note that technology is my middle name, application technology strategy, and how it can happen in the right way. Now, here's a key point, and Armand, listen to this and see if you don't recognize this. Satellites provide instant infrastructure. That is in critical times of need and well into the future. So I do believe that, and exactly what the structure will look like in 20 years, who knows, but it will be there. Thank you for your attention.
Thank you, Bruce. That's a very comprehensive view. And Bruce, I just have one question. You've listed a lot of key technologies. Which one of those are you most bullish about, and you think will have the most impact in the coming years? Software-defined satellites. Take your pick. Just pick one.
Well,
AI.
I would say onboard for the satellite, onboard processing and digital beamforming.
Okay, and for the ground network?
Network management systems and software-defined network.
Okay. The other panelists, do you have any questions for Bruce? None? Okay, then we move on.
Just let me just comment about Armand's discussion of direct-to-device, D2D. I didn't
we can
touch
do that
on
later at the end. So let's finish. Yeah, we'll revisit that. We'll finish the panelists. Last but not the least, Thomas Wrede, the founder and managing director of Technology Vision Consulting. And he worked for many, many years, 28 years, in fact, with the largest satellite company in the world, the SES, where he was the VP for new technologies. So he has his finger on this. During his stint at SES, he was the forerunner of the tech days, where they looked into new technologies and future technologies as well. He's very much involved with the DVB, so he will talk about broadcast applications for satellite. Thomas?
Hello, everyone, and thanks for the kind introduction, Virgil, and also thank you to you and Intersputnik for putting this conference format together. I think it's a great opportunity to exchange and discuss our views about the satellite industry and where it will be going. So as you said, Virgil, I participate in this conference on behalf of the Digital Video Broadcasting Project, referred to as DVB, where I'm chairing the Commercial Module Satellite Group, and I'm reporting to the Commercial Module and its chairman, David Pilo of the European Space Agency. So that's these blue letters, DVB, you see on the cover slide. What is DVB? It is basically an industry-led consortium of the world's leading media and technology companies working together to design open technical specifications for digital media delivery. And DVB was founded in 1993. That's when digital television was planned and then launched in 1995, 1996 in Europe. And in the DVB, I should mention that I currently represent the satellite operator SES of the Grand Duchy of Luxembourg. DVB has an interesting concept, which I like a lot and still not get tired contributing to it after 30 years. Because it has a concept of a commercial module and a technical module. What does it mean? It means there won't be any technical specification developed unless there is a commercial need by at least 5 member companies, and there are respective commercial requirements. So it's not technology for technology per se, but there is a commercial need when DVB engages in specification development. And since about two or 3 years, this technical development is even followed by a validation and verification process. This result then is published in a blue book that usually serves as an input for a formal ETSI standard. So concerning broadband and broadcast satellite application, I'd like to mention 3 important DVB standard developments this afternoon. One is the return channel system RCS2 for non-geostationary satellite orbits. This is an update of the DVB toolbox to serve non-geostationary constellations. It's basically an update of the DVB S2X and DVB RCS2 standards. Very important development. It's currently in its validation and verification phase. It will be used by an important and by a big satellite operator. The second standard I'd like to refer to is DVB NIP. Native IP for delivering live TV, VOD plus documents and other files via satellite to consumer homes, community places, or terrestrial gateway sites. Could be mobile phone base stations, obviously. The third one is DVB-I. It's another very important topic for DVB. That is a standard that allows viewers to seamlessly find and watch television content, whether delivered over terrestrial, satellite, or cable broadcast. And it includes any kind of broadband network. So for today, I like to focus on the latter 2, namely on DVB NIP and DVB-I. So this brings me to the slide which you see since a few moments already. And this slide basically was the starting point for DVB native IP. It just illustrates in a diagram our vision where satellite broadcasting is going in future. Coming from, on the left side, today's linear MPEG-2 transport stream delivered broadcast to set-top boxes, to integrated TV sets. And on the right side, it shows our vision how broadcast satellite television will be delivered, let's say tomorrow in the next generation, in a DTH, call it 2.0, 3.0, whatsoever, where it is delivered as file-based, IP-delivered video without the transport stream. Hence, we call it native IP. And this signal, this broadcast reaches IP gateways, it reaches IP set-top boxes, but it can also reach 5G towers, community places, CDNs, etc., etc. So it will be a much more universal delivery, and basically it brings together the best of broadcast and over-the-top delivery. And I think that is a very important vision where satellite broadcasting shall be going, let's say, in the next decade. NIP is a standard, it's available, it's a result of a good year of technical work by a representative of more than 13 DVB member companies. And it's basically out there at the moment, it's being field trialed. So let's move to the next slide, please. So on this slide, basically, yeah, you see how DVB NIP is functioning. So basically, what the thinking behind DVB NIP is to use the efficiency of broadcast networks for large-scale content distribution to IP devices. So fully integrating broadcast technologies with those used in broadband networks. That has an important advantage, and you see that on the left part of the slide, because you see that the operator can use its origin packager and the adaptive bitrate encoder and the whole technology most broadcasters have today in place to serve via streaming servers the internet delivery. They can use that same setup, that same hardware, that same mechanisms to also feed a DVB native IP headend, where the unicast is turned into multicast, IP encapsulated and beamed up to the satellite. That, I think, is a very important feature of DVB NIP. Then from the satellite in the downlink, DVB NIP can reach professional gateways. So that can be at a 5G tower, that can be at a public access point. Imagine a village somewhere in Africa or a place in Indonesia, in wherever on the planet, in markets where there is not fiber around every corner, you can reach public access points with native IP, and then they deliver the unicast from the gateway to the handheld devices, to mobile phones, tablets, any IP device, and allow the delivery of live video over the top, and very important also of file delivered content. So that basically would be in many cases distant learning content. But it can also at the same time reach the consumer home. Like with today's set-top boxes, you would have a gateway, and that gateway in addition also would serve IP devices in the home. So that is what native IP can do and can achieve. So let's go to the next slide. DVB, I should mention that it uses or reuses many existing DVB standards. So among them, the DVB-I, DVB-, the MABR, multicast adaptive bitrate, generic stream encapsulation, and of course, the more popular standards, DVB-S2X and DVB-T2 for the physical transport. But also it uses DVB home broadcasting for delivery in the home. So NIP currently, and that's what the next slide shows, is in a field trial phase, mainly in South America. And one trial is happening in Peru, where during COVID, the government realized that it had no effective means of communicating critical public health news to the entire population, as over 30% of the population in Peru is without internet connectivity. So they issued a tender, and that was issued by the National Institute of Radio and Television of Peru, IRTP. And in that tender, NIP, so somebody had looked at what DVB was doing, so NIP was specifically requested in the solution. And then a consortium of companies like ST Engineering, EKT, Quadrille, Easy Broadcasters, they launched a multi-year phased implementation phase, starting with live video, and that was then followed late last year, early this year, with file-based delivery of distant learning content. They use Eutelsat group satellite capacity to deliver the content to all the test sites. And the system uses DVB S2X, which is the most modern, most efficient broadcast standard and broadband standard over satellite in KU band. And they use also a new kind of set-top boxes that function as native IP gateways, as shown on the previous picture. So with that content, basically, every household in Peru can have the same number of channels, same HD quality, and access to file-based content delivery for distant education. And this will allow for potentially for true social inclusion and digital transformation of households in that markets. So we are already at the next slide, I see. Can you move one slide back? It's going a little bit too fast for me. Thank you. The next topic, and I mentioned I want to focus on NIP and on DVB-I. DVB-I is a standard that is an internet-centric mechanism to signal and discover television services, whether they are delivered over IP networks or broadcast networks. And DVB-I is published in the DVB Blue Book A177. It's not a new transmission or physical layer standard. It's basically the glue to signal digital media services over satellite or over terrestrial networks, including 5G and beyond. And DVB-I helps end users in setting up and maintaining their devices to easily discover new services. There are field trials ongoing in a number of countries, among them Germany, Italy, and Ireland. And I think the next important step for DVB-I shall be the official launch in several of these markets, which then also will kick off the integration of DVB-I in consumer TV sets and set-top boxes and other end-user devices. I think that is a very important step, and I think it will happen in the next months, so still in 2025. By reaching the market with an official launch of DVB-I. If we go to the next slide, please, and that's also the last slide, actually. So what DVB-I is doing, and it's live on Astra 19.2 degrees over Europe. It's also transmitted over a Eutelsat satellite. It brings regionalized channel lists and hybrid content delivery to the end consumer device. So this is very cool because the end consumer can then choose among different channel lists of his preferences with different languages, different thematic groups, and it then tunes basically the device, the tuner, and it stores the channels more or less automatically. That is a huge advantage considering, at least in Europe, the hundreds of channels we can receive here. But DVB-I can do more. It can integrate it in a flat screen, also from this channel list, provide access to content that is coming over the internet, that is internet delivered, for example. So it's a very consumer-friendly implementation and will enhance the delivery of satellite broadcast services, basically. Right, that's my short presentation for today.
Thank you very much, Thomas. Unfortunately, we're running out of time. So very quickly, Thomas, the whole theme of this conference is about opportunities and trends. As we all know, the broadcasting part used to be a very big part of the revenue stream for operators. You know that very well with SES,
yes.
up to 60 to 70%, and now it's a lot less. So how do you see it going forward?
Yeah, okay, that's a question I honestly expected, Virgil. Broadcast is not dead. Broadcast, whether satellite or terrestrial, will go on for many years to come. It's a very cost-efficient means of reaching millions of viewers in whatever market segment. I admit, yes, it is declining by 6, 7, 8, 9%. I think the big question of the satellite operators is, will this decline accelerate over the next few years? But it is still a very profitable business for the satellite operators, delivering, I think, the budgets to engage into multi-orbit strategies, new broadband adventures, etc., etc. So what will happen? I think, yes, traditional broadcast delivery will decline. In the existing markets, the satellite operators have to make satellite broadcast delivery as cost efficient as possible. So that means probably less satellites, using capacity even more efficiently as they do today, bringing down the cost. But at the same time, and that is important, I think, for new markets, for emerging markets, they have to look into new technology like native IP.
Right.
And I think that can be the future of satellite broadcast.
Yeah.
But it's not going away.
Not going away, Chris. That's very good. Thank you for your insight. Well, unfortunately, we've really run out over time, and the next panel is waiting now. So we'll have to forego the further discussion and question and answer, but you can use the chat button if you want, and then we will try to address your questions. So thank you very much for this very enlightening and very interesting presentations from our panel.